Okay, good morning. Let us start with the class. Okay, before I start with LCM, I will discuss two things. Number one is in exercise 4.2, you all had some doubts like divisibility by 45. Now, for divisibility by 45, we know that 45 is equals to 5 into 9. So you will test for divisibility by 5 and divisibility by 9, and if it is divisible by both, then only it is divisible by 45. Now another one was 6. Now 6 is 2 into 3, product of two prime numbers. We are seeing it in that way. So if it is divisible by 2 as well as by 3, then it is divisible by 6. And one more question was there. A number is divisible by 3 and 24. By what other numbers will that be divisible? Now in this case, you have to find out the product of 3 and 8, because 3 and 8 are co-prime numbers. So 3 8s are 24, so the number will be also be divisible by 24 and all factors of 24. So let's do that only. Number 13 from exercise 4.2. So exercise 4.2, question number 13. Okay, so they've said that the number is divisible by 3 and 8. So let the so as 3 and 8 are co-prime numbers, you know what is the meaning of co-prime? They have only 1 as their common factor. Co-prime numbers, then the number which is divisible by 3 and 8 will also be divisible by 24. Okay, the product of 3 and 8. Okay, so it will also be divisible by all factors of 24. Okay, so it will be divisible by the product of the number and all the factors of the product. So what are they? Let us find out the factors of the product. So 1 into 24, 2 into 12, 3 into 8 and 4 into 6. The next one will be 6 into 4, so that means repetition, so we stop. So what are the factors? Therefore the number is divisible by which numbers? 1, 2, 1, 2, 3, 4, 6, 8, 12, 24. 1, 2, 3, 4, 6, 8, 12 and 24. Okay. Okay. Now let us start with prime factorization. Now what we did just now with 24 was simple factorization, only factorization. So 1 into 24, 2 into 12, 3 into 8 and 4 into 6. So this is only factorization, because we have expressed 24 as the product of two natural numbers. It can be prime or it may be not prime. But when you express 24 as a product of only prime numbers, then that becomes a prime factorization. So how will we do prime factorization? We will do the division method. So what we are going to do is we are going to start dividing 24 with prime numbers. Now what are the prime numbers we have? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31 in this way. Okay, so we are going to divide 24 with a prime number and we will start checking with 2. For every division we are going to start checking with 2. So now this is an even number, so I can divide it with 2. So 2 ones are 2, 2 twos are 4. Again I am going to divide it with 2, 2 because 2, this is an even number. So 2 6 are 12. So again it's even number. Again I can divide it with 2. So that is 3. Now again this is another division. Now I will again start checking with 2. I cannot divide 3 by 2. So this now 2 cannot be used. Now I will check with 3. Yes, it can be done. So 3 ones are 3. So what can you write over here? That 24 is equals to 2 into 2 into 2 into 3. So this is called prime factorization, where the number has been written as a product of only prime numbers. Okay. If you have any problem, just let me know over your WhatsApp group or live chat. Okay. So nobody is having any problem. So I will move forward to my next sum. Let us find out the prime factorization of um, 150. Okay, 210. Second example, 210. So we will start with 2 because this is an even number. It ends with an even number. So we can divide 210 by 2. So what will you get? You can do the division in the rough column if you want, or you can do it mentally. So 2 ones are 2, 0, 2 5s are right. See, you can do such divisions, you can do such divisions in the rough column. 2 ones are 2. See, 1 is coming down, but you cannot divide, so that is why I am putting a 0, and then I am bringing down 0, and so 5s are 10. Okay. So now 105. Now next division, I will again start trying with 2. So see, this is an odd digit, so it cannot be divided by 2. So 2 is not my option. Then I will go with 3. So how do I know whether a number is divisible by 3 or not? We will add the digits. 1 plus 5, 6. And 6 is divisible by 3. So I can use 3. So 3 3s are 9, carry 1, 3 5s are 15. Again division. Again with 2 it is not possible, with 3 it is not possible because 3 5s are 8, This is for the new division. Okay, 2 it's not possible because it's ending with a odd digit. 3 it is not possible because 3 3 plus 5 is 8 and 8 is not divisible. 4 is also not divisible. 5 is divisible because it's ending with a 5. So 5 sevens are 35 and 7 is a prime number. So I will to use 7 itself. So we are going to continue doing this division until we reach a 1 at the end. Sometimes, few people they choose to end over here, that is we come down to 7. But what happens is, when it becomes a very unknown or non-popular prime number, we think that maybe it is not a prime number, it is a composite number, but by mistake we think it is to a prime number and we stop division, and you will go wrong in that case. So you can do this where I go on dividing until I reach 1. So 210 can be written as 2 into 3 into 5 into 7. See, 2 into 3 is 6, 6 5s are 30, 37s are 210. So this is product of all prime numbers. So this is the answer. Okay. Now let us do LCM. Okay. Least common multiple. So let us see what are the multiples of 30. Multiples means 15 ones are 15. This is one multiple. Which is the next multiple? 30. Then 45. So in this way we have the multiples 15, 30, 45. The next one is 60. Then you have 75. Then you have 90 and so on. Now let us see what are the factors of. Oh yes, I can see many students had raised voice. Miss, it will be multiple and not factors. Okay, somebody here wants to know. Prime factorization did not understand. Mm, Okay, tomorrow also I will be sending you a video on prime factorization because I'm already done with prime factorization. I think you entered the class late, so you have missed a lot. So tomorrow in the video you can see it, or today itself after the class is over you can go through this video again. Now another one is okay, we can also divide a number that is not a prime number. No, when in prime factorization you cannot divide a number which is not prime. We will always have to divide by prime numbers. That is why it's called prime factorization, expressing it as a product of only prime numbers. Now let us see what are the multiples of 24. Okay, so that means 24 ones are 24, 24 twos are 48, 24 twos are 48. So ones are 24, twos are 48, threes are 72, fours are 96, fives are 120. Now see, till 90 I've written here, and this is till 90. We don't have any common multiple, so that means the common multiple is beyond this range. See, I've reached 120 over here, so let us extend this range also. So after 90, after 90, what will you have? 105. Then you will have 120. Now see, I've got a common multiple, isn't it? 120, 120. Okay. Again, you will have the next one will be again 240 will be the common multiple. Okay. Again you will have multiple, you will have 360, then 480 in this way. So but the first one is 120, which is the minimum. the least common multiple. This is the least one. Then you will have many more common ones after this, but the first one was 180. So your LCM will be, sorry, 120. So your LCM will be 120. Okay, this is the meaning of lowest common multiple. Now, what is the interpretation of the lowest common multiple? Suppose there are two students, A and B. Okay, and they are playing a game where each one of them, A throws 15 matchsticks at a time in a bucket, and B is throwing 24 matchsticks at a time, or you can say marble. Okay, 15 marbles at one time in one bucket, and B is throwing 24 at one time in a bucket. So each time they throw, so first throw, A will throw 15, B will throw 24. Again in the second throw, B will again throw 15, but in the bucket how many will be there? 30. B will throw 24 marbles. Now in the bucket you will have 48 marbles. So after the third throw, in A's bucket will have 45 marbles and B's bucket will have 72 marbles. In this way, after 1, 2, 3, 4, 5, 6, 7, 8. So, and this is 1, 2, 3, 4, 5. So, after after the fifth throw, what will A's bucket, how many marbles will be there in A's bucket? In A's bucket, 75 marbles will be there, and in B's bucket, 120 marbles will be there. Now, again, it will go on throwing. So, after the 8th throw, A will have 120 marbles and B will have some more, but after 8 throws, A will be able to accumulate 120 marbles in the bucket and B will be able to accumulate 120 marbles only after 5 throws. So this is the meaning of LCM, that at what uh, point of time will they have the same number. Okay, they are throwing unequal number of marbles, but they will have, at some time they will have the same number of marbles, but A will have it after 8 throws and B will have after 5 throws. Okay, is that clear? If you want, I can explain this once more with another example. Okay, let me see if anybody has a problem. There are a few questions. Okay, she we have to write in the rough column the numbers. Okay, now see, it is up to you. Rough column is, you can write anything in the rough column that is going to help you do the sum correctly. So you can write the numbers in the rough column. Okay. Um, okay. One of the students wants this to be explained again. So I will repeat this with an example. Let us take for example father and child. Okay. Now this is the child. The father can jump 3 stairs at a time, and the child can jump only 2 stairs at a time. Okay. So in this way, every time the father jumps, he is crossing three steps. Okay. This is the first jump, second jump, third jump, fourth jump, and fifth jump. Now, how many stairs is he covering after each jump? After the first jump, the father has completed 3 stairs. After the second jump, he has covered 6 steps. 3 plus 3, 6. Okay. Now, after the third jump, he has covered 9 steps. And after the fourth jump, 12. And after the fifth jump, 15. So, in this way, every jump, 3 steps, the father is coming down. Now the child is jumping 2 stairs at a time. So in the first jump, he has come down by 2 stairs. Second jump, again 2 stairs. So but he has completed come down by 4. So 2 2. Again in the third jump, 2 more stairs, completed 6. Again after 2, another jump, 8 stairs. Again another 10 steps. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So each father and child, they have jumped 5 times. They have jumped 5 times. Now see, here we have a 6 and here also we have a 6. What does this mean? It means that if the father and the child starts jumping the stairs together, at the 6th step, they will come together again. See, I'm giving you an illustration. Suppose these are the stairs. 1, 2, 3, 4, 5, 6. These are the 6 stairs. Okay. Now, the father, first step was over here, jumped 3 stairs, right? 1, 2, 3. 3 stairs. And the child, first jump, he reached here. Again, the father after the second jump reaches here, but after the second jump the child reaches over here. Then in the third jump he reaches over here. So you see in the sixth step, sixth stair, they are coming together. So this is the first common multiple of the number of stairs they are jumping. So that is the LCM of 3 and 2. The number of times that they are jumping, that is different, but this multiple is same. And this is the first multiple where they are coming together. Again you see, if the child jumps again for the 6th time, he will cover 12 stairs and the father has already covered 12 stairs. So what is happening, again in the 12th stairs they will come together. Okay, so this is the interpretation of LCM. Two different numbers in increasing its multiples, first multiple, second multiple, third multiple, but there is a common number where they are equal. So that number is and the first number that happens to be like that is the LCM, lowest common multiple. No, the examples you need not write in the copies. So this is just an illustration, so you may not do it in your copies. I am giving you 2 minutes to copy to finish whatever writing work is left to be done. You may not copy this father-child example. You can skip this part. Okay, I will be taking attendance now because I'm seeing only 50% of the class is present every day. So I want the attendance to be better. Okay, now let's start the exercise. Exercise 4.5. Question number 1. 1 subpart 2. You have to find out the LCM using the prime factorization method. So when it is the prime factorization method, we have to factorize each number separately and express it as a product of prime numbers. So let us do number 2. 36, you have to find out the LCM of 36, 40 and 126. So let us find out the prime factorization. 36 separately, okay? 2 ones are 2, 2 eights are 16, again 2 nines are 18, again 3 threes are 9, 3 ones are 3. Then you have 40, 2 20s are, 2 10s are, 2 5s are, and 5 ones. Again 126, 2 63. It will not go with 2 anymore because it does not end with the prime even digit. So 3 21s are, 3 7s are, 7 ones are. So let us write down. Now I am writing on this part of the board, but you can write this below over here. Okay. So let us express 36. Write down this way: 2 into 2 into 3 into 3. Then let's write 40. 2 into 2 into 2 into 5. And 126 is 2 into 3 into 3 into 7. Okay. Now let us see what are the different prime numbers that are there in all these numbers. Okay, that will be my LCM. So in the rough column you can do this, that I have a 2, see 2 is there, 3 is there, 5 is there and 7 is there. So I will write down all these numbers: 2, 3, 5, 7. Now let us see how many times 2 is there in each one of them. Here there are 2 is 2 times, here 3 times, here 1 time. So which is the maximum? This one, right? 2 is 3 times. So I will give 2 into 2 into 2. Okay. Now let's see 3. 3, here it is 2 times, here none, that means 0, here 2 times. So 2 is the maximum, that is 3 will be there twice. 5 only once it is there, so only once. 7 also once. So now you will multiply all these numbers. Okay. So 2 into 2, 4, 4 into 2, 8, 8 threes are 24, 24 threes are 72, 72 and this is 35, right? Now you can do this multiplication in the rough column and you can give the answer. You can do it over here. Let's see. Yes, the answer is correct. 2520. Okay. See, 5 twos are 10, 5 sevens are 35 and 1 36. 2 threes are 6, 2 sevens are 20, 2 threes are 6, 2 sevens are 21. So 0, 2 carry 1, 5, 2. So the answer is 2520. Does anybody have any problem in this question? Okay, no questions. So let us do another one using the prime factorization method. Twenty-four, 28, and 196. So this is ones apart 4. 24, 28, and 196. 24, 2 12s, 2 6s, 2 3s, and 3 1s. Then 28, 2 14 times, 2 7s are 14, 7 1s. And 196, 2 9s are 18, 2 8s are 16. Again with 2 because it's ending with an even digit. 2 4s are 8, 2 9s are 18, 7 7s are 49, 7 1s are 7. So let me write this down. 24 is equals to 2 into 2 into 2 into 3. 48, not 48, 28. 28 is 2 into 2 into 7. And 196 will be 2 into 2 into 7 into 7. So the LCM. What are the different types of prime numbers we have? We have 2, we have 3, and we have 7. Now let's see how many times each one of them is there. Here 2 is 3 times, 2 times, 2 times. So this is the maximum over here. Okay, 3 times. So here also 2 will be 3 times. 3, there is only once over here. So it will be there once. And 7, see here 7 is once and here it is twice. So this is the maximum. So 7 will be twice. Which is 2 into 2 into 2 is 8 into 3 into 49. So that is 24 into 49. And do the multiplication in the rough column. 36, 18 and 3 21. 4 4s are 16, carry 1. 4 2s are 8 and 1, 9. So 6 7 1 1. So your LCM is 1176. Now let's move on to the division method. Question number 2, subpart 3. Find the LCM of 24, 40. Find the LCM of 24, 40 and 84. Okay. What were the numbers? 24, 40 and 48. Let us divide with 2. 20. Oh, sorry, it was 84, no? So this is 42. 2 6 are 12, 2 10s are, so it's 21. So I will go on dividing until we have something to divide. Which is not divisible, I will just bring it down as it is. This is a more secure way of doing it. See, 2 1s are 2, 2 5s are 10, 7 is not divisible. 5, we will continue until we get all 1 in this part. So this is 7. These are not divisible. This is 1. So your LCM will be the product of all these numbers. Okay. Which numbers? All these factors that you have got will be your LCM. So 2 into 2 into 2, 2 into 2 into 2, into 3, into 5, into 7. Somewhere here I went wrong. No problem. Yes, now the answer is correct. 8 correct. Okay. I'll do one more using the division method. This will be today's last sum. Okay. 2 subpart 4. 20, 36, 63, 77. So 7 plus 7 is 14. So 14 is not divisible by 3. So we'll start with 2 because we have something. 10. 2 10s are 20. 2 18s are 36. This is not divisible. This is not divisible. We still can divide something with 2. So we continue. 2 5s are 10. 2 9s are 18. This is not divisible. This is not divisible. So let us bring in 3 now. See, 3 3s are 9 we have, and we have this one also. Not divisible. 3 3s are 9, 321, and not divisible. Again, we can divide something with 3. This is not divisible. Whatever is not divisible comes down as it is. 3 1s are 3, 3 7s are 77, not divisible. Then we have a 5. Then we have a 5. 5 1s are not divisible, not divisible. Then we will bring in 7, 1, 1, 1, 11, and then finally 11. So we have reached all ones. So your LCM will be the product of these numbers, 2 into 2 into 3 into 3 into 5 into 7 into 11. So 2 into 2 into 3 into 3 into 5 into 7 into 11. Okay. Now you can do in the rough column or you can do it mentally also. So 2 2s are 4, 4 3s are 12, 12 3s are 36. So this is 36, this is 35, and this is 11. So now you can multiply 36 into 35 into 11. Yes, the answer is 13860. 13860 is the answer. Okay. So with this, we will end today's class. Tomorrow I will send you a video on HCF and LCM also. And so we will complete chapter 4.